Welcome to the AI Research Roundup. I'm Alex. Today we're diving into a comprehensive system card that details a new frontier model featuring a novel mechanism called adaptive thinking. This model achieves state-of-the-art performance across diverse domains, hitting a remarkable 94% on the ARC-AGI benchmark. The publication is titled System Card, Claude Opus 4.6. And as we'll see later, the implications for both safety evaluation and autonomous agentic behavior are quite significant. Moving to Table 2.3.a, this summary breaks down performance against key competitors and previous models. Claude Opus 4.6, listed in the first data column, shows a massive leap in reasoning on the ARC-AGI benchmark, hitting roughly 69% compared to just 38% for Opus 4.5. It also secures a strong lead in coding environments, evident in the terminal bench 2.0 score of 65%. While it dominates in the specialized agentic and reasoning tasks, general knowledge scores on GPQA Diamond and MMMLU remain highly competitive, often within a percentage point of GPT 5.2 and Gemini 3 Pro. Figure 2.5.a illustrates these coding capabilities in detail by comparing pass rates on Terminal Bench 2.0. On the right, 3 orange bars represent different effort levels for Opus 4.6, demonstrating its adaptive compute usage. The maximum effort mode achieves the top score of 65.4%, clearly surpassing the previous Opus 4.5 model shown in green. Even the medium effort setting remains competitive with the best GPT 5.2 codex result, scoring over 61% while generating fewer tokens. Figure 2.9 plots these scores against cost per task, revealing a dramatic efficiency advantage. In the top graph for ARC-AGI, the orange curve representing Opus 4.6 spikes to that 94% peak while keeping costs relatively low. By contrast, competitors like Gemini 3 DeepThink, shown in gray on the far right, trail behind in accuracy despite costing significantly more. The bottom graph for ARC-AGI confirms this dominance, where Opus 4.6 maintains a massive lead over both its predecessor and the GPT 5.2 series. Moving on to specialized domains, Figure 2.14.4.a presents results for a real-world finance evaluation. This test is demanding because it combines code execution with tool use to gauge actual financial workflows. The blue bar on the left shows Sonnet 4.5, starting at 40.8%. In the middle, the green bar indicates that the previous Opus model already made a large leap to 58.4%. However, Opus 4.6, shown in orange on the right, sets a new high watermark at 64.1%, confirming its superior capability in complex professional domains. Alright, shifting gears to long context reasoning, Figure 2.1.8.1.a shows performance on the OpenAI MR-CRV2 benchmark. The left chart focuses on a 256,000 token window, where the two Opus 4.6 bars in orange and dark red soar above 90%, completely eclipsing GPT 5.2, which sits at roughly 64%. The difference is even more stark in the right chart, which tests a massive 1 million token context. While competitors like Gemini 3 Flash drop to about 33%, Opus 4.6 maintains high accuracy, scoring over 78%. Moving to a broader challenge, Figure 2.2.1.2.a presents results on Humanities Last Exam, or HLE, which tests advanced general capabilities. On the left, without tools, Opus 4.6 takes the top spot with 40% accuracy, surpassing both Gemini 3 Pro and GPT 5.2. The right chart shows what happens when models can use tools. Here, performance improves universally, but Opus 4.6 maintains its dominance. It achieves 53.1%, clearly outperforming GPT 5.2 Pro, which tops out at 50%. Figure 2.22.a breaks down performance in life sciences. Across 5 distinct domains, ranging from organic chemistry to structural biology, Opus 4.6 in orange consistently leads. The top left chart for BioPipeline Bench shows the most dramatic gain, where the new model nearly doubles the score of Opus 4.5. Crucially, in the top middle panel for Biomystery Bench, Opus 4.6 even surpasses the dashed human baseline, achieving over 61% accuracy. Turning to safety metrics, Table 3.1.1.a evaluates how often the models refuse harmful requests. The first row shows that Claude Opus 4.6 achieves an overall harmless response rate of 99.64%. This performance is effectively tied with the previous Opus 4.5 model, confirming that increased capability has not compromised basic safety alignment. Crucially, the rightmost column demonstrates that enabling extended thinking raises the safety score to 99.74%, suggesting that deeper reasoning allows the model to better detect and reject unsafe prompts. Wrapping up, two main takeaways stand out from this system card. First, Claude Opus 4.6 delivers a massive jump in reasoning and agentic utility, dominating benchmarks in coding, finance, and science. Second, while standard safety metrics remain solid, the subtle rise in deceptive behaviors highlights the growing importance of advanced monitoring, like the ASL3 standard. That's it for this episode of